Great, thanks so much. Another very clear talk. And so do we have any questions? We have one on Slack, which actually is very similar to a question on the previous talk, which is about the limited processing performance of what happens on the SmartNIC, and really, you know, how much is it really worth trading things off with offloading work onto a NICs with a bunch of, well, in the case, let's see, this is from, if you look in the Q&A on Slack, it's from Japan Yan, and a question about NVIDIA Bluefield 2 and the kind of lack of oomph and power you get from the processors there. I mean, in a way, this is sort of generic question about SmartNICs, which is, I guess, all papers working, all people working on this is, what is the ideal SmartNIC? You know, do you want something that has a really high amount of processing power, really low latency to the host memory, and doesn't cost very much, I guess. But Jongyul, do you have any feedback on that?
Can you repeat the exact question about, yeah, in Slack? I didn't get.
Yeah, I think that the question is really just about the limits of the processing power, and you mentioned that briefly in the paper. But you know, what would an ideal SmartNIC processing performance look like for the LineFS case?
Right. We use the Bluefield first generation Bluefield SmartNIC, and it has 16 ARM cores, and it supports only 25 gigabit per second network speed. And to fully saturate the network bandwidth, we use about 60% of total CPU resource of SmartNIC. So yeah, maybe to support better throughput, we can use another the second generation, for example, second generation of SmartNIC. It will use more CPUs, but it has more faster cores. So yeah, we didn't see that the CPU resources limited in our benchmarks.
Okay, thanks. And then the second question is from Jing Huang.
Hello, I'm Jing Han. I have one question. Like if we do the resource allocation and isolation in the host CPU, and we use some host CPU codes to do the SmartNIC work, so what does the SmartNIC do? And can we achieve the same performance compared with the SmartNIC offload approach?
Yeah, right. We can achieve the same throughput our LineFS support with only using the host CPUs, but some tasks. So the object of our paper is to reduce the application interference in the host machine, and the interference comes from the distributed file system operations. So we want to remove the resource usage of distributed file system, of host resource usage of distributed file system by offloading SmartNIC. So that is our purpose of our paper. And other than that, for example, there are some tasks that is very inefficient if we run on the host CPUs. For example, polling the RDMA completion queue, it provides better latency for the distributed file system operations, but it takes 100% core resources. So it is very inefficient if we do some polling on the host CPU, but we can use slow SmartNIC CPU to poll the RDMA completion queue. That kind of operations is very good candidates for offloading to the SmartNIC. So yeah, we wanted to provide that design in our paper.
Okay, thanks for your answer. Thank you.
Thanks. And Aditya Tiwari?
Yeah, hi. Great work. This is super cool. I had a quick question about how you're decomposing the problem on the throughput and latency problem on the SmartNIC, where you basically use pipelining in order to solve that. Is there a reason that you can't use something like out of order execution, like a separate algorithm like that? Is it because the latency for each like fetch and decode stage is too uniform?
So your question is there any benefit to use out of order execution on SmartNIC? Actually, as I know, it executes in order. It is an in order core. I think it executes in order in the SmartNIC CPU. So
I mean, specifically when you're like doing your decode, your fetch from the network phase, not the architecture of the core itself. I'm talking about the algorithm you're using.
Right. So out of order execution, that's great idea, but there is a consistency issue. If there is a crash in distributed file system, then it is hard to provide the it is hard to recover the log data if their execution is logged in reverse order. So yeah, I think that's the problem if we adopt the out of order execution in our pipeline parallelism.
Okay, thank you.
Okay.
Thanks.
I was just thinking though that if you have a kind of distributed file system with idempotent operations, then it's up to the application to decide that there's some ordering constraint, and if it's rare, then you could do out of order operations and just insert. You could use the previous paper to insert transactional semantics in the rare case that you needed them, yeah. No, never mind. That's just a crazy idea. Maybe we'll look at that next year. I think I don't see any more questions. I think there's a follow-up question about what would happen if you need a more powerful processor on the NIC. I mean, in general, or the main host. In general, I mean, there are cases where you have some kind of complicated file system thing where you do, I don't know, network coded files or something where you might want to do that offloaded on a NIC, but then you need a lot more processing on the NIC to do that. So that would be a kind of very specialized application. I think we're out of time now. So thank you very much. Great response to all the questions, and we should move on to the third paper in this session. And then we should have a bit of time at the end. Maybe if there are any general questions across all the speakers, if we have time, we'll try and do that. But the third paper is on automated SmartNIC offloading insights for network functions. And the presenter is Yimin Kyu, who's a second-year PhD student at Rice. So if you could play the video now, and then we'll be around for questions at the end of that. Thank you. So if we could.
Okay. If you have any questions, please raise your hand. Oh, Jongyul is here. Good morning, Jongyul.
Hello.
So to kick off the Q&A session, I will ask the same question actually. How fundamental is it to use SmartNIC? So you assume that the CPU is busy. That's true. It's busier. What if you have leftover CPU cores? And what if you actually run the workload that you currently run on SmartNIC on CPU cores? Do you still think using SmartNICs better than using CPU cores?
So your question is that other than the CPU.
My question is that yeah, using extra computation power is good, right? That's good for improving throughput, whatever. Yeah. But then what if but your assumption is the CPU cores are CPU cores are very busy, so you cannot really do anything with CPU. But let's say, just for the sake of arguing, right? Let's say the CPU cores, you have some CPU leftover CPU cores. Is it better to run workload still at SmartNIC, or is it better to run at CPU? So that's the question is how fundamental is it to use to SmartNIC?
Right. Actually, using the host CPU gets a better throughput than using the SmartNIC in most cases when CPUs are idle. So, yeah, other than the performance, we can provide, for example, in our paper, we mentioned the extended availability that utilize the separate failure domain. I mean, the SmartNIC can operate and access to host percent memory even if a host OS is crashed, and that provides additional availability in distributed file system domain. And
do you still support read from SmartNIC too?
So
as I understand, you kind of use it for writing, right?
Writing. So do you
publish, right?
You mean the write some
so
data
say,
writing?
Okay, please go ahead.
Yeah, actually, basically the purpose, our goal of our paper is just to, reducing the host resource contention, because offloading DFS tasks to the SmartNIC, and we want to say that some tasks like polling RDMA completion queue that is very inefficient running in host CPU. That kinds of tasks can be executed on the SmartNIC, and it can provide a better latency because it is very inefficient to using 100% core of host CPU cores to just doing a polling. Yeah, that may be an example of why we can use SmartNIC in either case too.
Okay. Any other question? Oh, yeah, yeah, please.
Yeah, thanks. Hello, I'm Ino from NUS. Thanks for the great talk. And my question is, it's interesting that you use the idea of the pipelining to increase the throughput of your system. So I wonder, in your presentation, you say that, for example, you use the 4 megabyte chunk size for your pipelining mechanism. So I wonder, is there some guideline to choose the proper chunk size and the implication of the chunk size in terms of the performance? Yeah.
Right. Actually, we didn't do further experiment to decide the chunk size, the proper size of chunk, but as we can increase the size of chunk, then we can there's a more chance to leverage our pipeline parallelism in SmartNIC, because the small chunk size means we need to send requests more frequently. That requires more CPU resources from host and SmartNIC, both in host and SmartNIC, and so we run with 4 megabytes chunk size, and it is enough to leverage our pipeline parallelism. So yeah, that's that was our decision.
I see. Yeah, thank you.
Okay, there are some questions at Slack. I think is similar to the question that I asked. So it's Choi, my MS student from USTC. I have two questions. Bluefield can be seen It's ARM CPU plus ConnectX-5 RDMA NIC. ARM CPU also controls the NIC through Linux OS. So it can be assumed that the programs you can run on ARM CPU can run seamlessly on the host CPU. Why not dedicate some host CPU cores instead of the ARM CPU? Does ARM CPU bring additional network performance benefits? That's the first question. Do you want to answer that first?
Right. Actually, from the perspective of network performance, it doesn't get any. We cannot get any benefits by running program on the NIC side, and other than the polling case I just mentioned before, and
okay. The second question is, host CPU is more computationally powerful, and assume that X host CPU cores are comparable to 16 ARM CPU cores in SmartNIC. Although offloading tasks to ARM CPU can save the host CPU, the ARM CPU is not free, and you need an extra budget to buy SmartNIC. Have you compared the price of X amount of CPU cores versus SmartNIC? Why not just use the budget to buy host CPU with more cores? So still, I mean, is it still better to use CPU cores, or just is it like more cost effective to use CPU cores or SmartNIC?
right. I believe the x86 core is much expensive than ARM core currently, but SmartNIC itself is quite an expensive device currently, but I believe its cost will goes down. And additionally, I want to add some comments on the first question. And we have some benefits when offloading the IO related tasks to the SmartNIC, because there is if IO requests are executed on the host CPU, then it generates it preempts application threads to handle the interrupts occurred by IO requests, So that scenario might offloading that IO request to SmartNIC can be one of the beneficial effect of offloading to the SmartNIC. And for the cost, for the budget, yeah, I think we need to calculate more about the exact price and power consumption. But what I only can say right now is SmartNIC uses less power than host CPU. It's only about 25 watt because it is connected to the PCIe socket. So that might be that would be beneficial for the operational costs. Yeah.
Okay, I see one more attendee raised the hand, but I think it's already time's up, so we can actually ask questions at the end of the session.